Welcome to 2.1, Transformations of Quadratic Functions, Part 1. In 2.1, you will learn to describe transformations of quadratic functions and to write transformations of quadratic functions. The first thing we will look at is quadratic functions is a function that can be written in the form of f of x equals some number a times the quantity x minus h squared plus k. This should look familiar to you from the absolute value functions. The graph is U-shaped, and that shape is called a parabola. We've already looked at some quadratic functions in the first chapter, so this shouldn't be brand new to you. So let's look a little closer. So let's look at the horizontal translations. The f of x, the parent function is f of x equals x squared. And then the horizontal that's right and left is inside the function. It's inside the function. It's inside the squared part, okay? Remember what I told you about the x's lie? Same idea here. So x minus a number goes to the right. X plus a number goes to the left. Vertical translations happen on the outside. So this number outside here moves it up. If it's positive, it moves it up. If it's negative, it moves it down. So let's look at example 1. We need to describe the transformation of f of x equals x squared, represented by g of x equals x plus 4 squared minus 1. Then graph each function. That includes the parent function and the g of x, the translated function. So before we even start, they want us to guess at what this is, okay? So we look at the numbers that are just other than x squared. So we have x or plus 4 on the inside of the function and minus 1 outside the function. That plus 4 inside, that is a right or left, okay? And since it's plus, it actually goes to left. Remember I told you it lies to you, okay? So this is going to be a transformation of 4 units left. And then the minus 1 on the outside, that's actually down 1 unit. So 1 unit down. And we want to graph these, okay? If you still need to use a t-chart, go for it. The original one, let's make it in blue. So just do f of x. Remember, f of x is equal just to x squared. So you know my favorite numbers, -2, -1, 0, 1, and 2. Then I'm going to square them. So we get 4, 1, 0, 1, and 4. So -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And you get this nice, smooth parabola shape, U-shaped. We're going to label this f of x. Now let's do g of x. Let's do that in green. We can move this physically, or we can do a t-chart. It's really kind of up to you. We know that we move every point 4 units left and 1 unit down, so we can take each one of these points, 4 units left and 1 unit down, and transfer them all. Or we can make a t-chart. It's kind of up to you. But notice how it's going to be symmetric around this point that's already graphed. Okay, that is the vertex. So 0, 0 is our vertex in our original one. And our new vertex is going to be -4, -1. Okay, and that helps center your graph. So if you're not sure after that point, you know that's your vertex. You know that is like the center of your parabola. It's the center of the U shape. And you notice that the parabola is symmetric. So we can pick points from that if you want. Let's try -3, -2, and then let's pick 2 on the other side of -4, so -5 and -6. We're going to plug those in. -2, so let's do g of x. I'm sorry. Plugging -2, aren't we? So we plug in -2 plus 4 squared minus 1. We simplify that to be 2 squared minus 1. 2 squared is 4. 4 minus 1 is 3. So -2, 3 is that point. We plug in -3. We can do that right here. Plug in -3. -3 minus 4 squared plus 4 squared. That would be 1 squared. 1 squared is 1. 1 minus 1 is 0. So we get a 0 right there. If we plug in the 5, we're going to get a 0. We plug in a -6, we're going to get 3. If you don't believe me, plug it in. You can do that. So -2, +3. It's right there. -3, 0. And then -4, -1 is already graphed. -5, 0. And -6, 3. So we have this nice parabola here. And you notice it's roughly the same size. It's not wider or narrower. It might look a little narrower because like my graphing, but it is not. It has only moved to the left 4 units and down 1 unit. The domain. Let's talk about domain and range while we're here. So domain, that's how wide your graph is. That is your x values. How far right does your graph go? How far left does your graph go? Well, in this case, it goes on both directions forever, so it's all real numbers. Your range is how high does your function go. So we know the lowest it goes is right here. That's the lowest it goes, and then it gets higher and higher and higher. So that depicts y is greater than or equal to -1. So that is our range. Remember, range describes your y values. So this is the domain and range for g of x. Let's take a look at reflections on the x-axis and reflections of the y-axis. So this is just repeat what we've seen this before. The reflections in the x-axis, that flips it straight down. Notice how the negative sign is outside the function. It's outside the x squared part. If you look at reflections in the y-axis, it is inside the function. Okay, and if it doesn't move right or left, you're not going to see any movement. Okay, because if I reflect this over that y line, that y-axis, it just maps right on top of itself. So it doesn't do anything. It doesn't do anything that we can technically see. But so if it's moved right or left, up and down, it will make some changes. Okay, so you won't see that unless you have a right or left translation. So let's take a look at horizontal shrinks and stretches. Remember, I talked about this last time. We are not doing horizontal stretches and shrinks. Most of these can be written as a vertical stretch and shrink, so we kind of don't do this. This is more of a pre-calculus topic, but it is on the inside of your function instead of the outside, so you notice that there's a theme going on here. Vertical stretches and shrinks happen outside your function, just a number right out front there. Okay, we will be doing the vertical stretches and shrinks, not the horizontal. Some things to note: it is a vertical stretch if a is greater than 1. That's like the number 2, 3, 4, something big. Okay, it is a vertical shrink if a, that number out front, is between 0 and 1. So if that number is like 1/2, 1/3, 0.2, something less than 1 but greater than 0, it is called technically a shrink. Okay, a vertical shrink. Saying way too much. Sorry about that, folks. Remember that you can think of vertical stretches and shrinks as a picture in like a Word document, that if you know the width stays the same and you pull it up and you stretch it out vertically, it will become tall and skinny. Same idea. The sides of your graph are going to be tall and skinny. But if you shrink it down and push it down vertically, it becomes short and fat. Okay, the sides of the graph become wider, and it's it's less steep. Okay, so that helps you remember that. Let's look at example. Let's look at example 2. Transformations of quadratic functions. So describe the transformation of f of x equals x squared represented by g, and then graph each function. So let's look at a. The only thing that's happening to a, g of x here, is this negative 1/2. Okay, so there's two things going on. One, it's negative, and it's outside the x squared part. So this is a reflection over the x-axis, or in the x-axis, however you want to say that. Then you have that 1/2. That 1/2 is a vertical shrink because it's less than 1 but greater than 0. So this is a vertical shrink by 1/2. And so let's graph that. All right, so we know the original. They just ask us to graph that function. They don't ask us to graph the parent function. So let's take a look at that. All right, so let's do x, g of x. Let's do a dual t-chart. Again, Desmos is a really great resource here. But I'm going to hand graph this. So first I'm going to square each one, and then I'm going to take the negative 1/2 of it. Okay, so negative 2 squared is 4. Half of that is 2, and it makes it, and makes that negative, so negative 2. Negative 1 squared is 1. Half of 1 is 0.5, and so it becomes negative 0.5. And I'm graphing, so decimals are great. 0 squared is 0. Half of 0 is 0, and 0 is no sign at all. 1 squared is 1. Half of 1 is 0.5, and you take the negative of that, so it's negative 0.5. 2 squared is 4. Half of 4 is 2. Then take the negative, becomes negative 2. So we want to graph these. Then we graph it. Let's graph these points. So negative 2, negative 2. Negative 1, negative 0.5, 0, 0. 1.5, 2, negative 2. And say if you wanted another number, you can totally plug in another number. I think 4 would actually fit. And you notice here this is all symmetric, right? 4 squared is 16. Half of 16 is 8. And that'd be negative 8. So that might help graph these, give it some extra points. So this is the parabola. Now without having the original on here, it's kind of hard to tell about like the vertical stretches and shrinks. So I'm going to plug that in here so you can kind of see that. And you'll probably start to memorize these points because of the parent function, because they're really, we use them a lot. So there is the original. This is f of x. This is g of x. So you notice it is wider, and it is reflected over the x-axis. So let's take a look at b. B is, let's choose a different color. All right, so the transformations of b. First of all, we notice that we have a number inside the function. Now, inside the function is typically a horizontal stretch or shrink, okay? Told you we're not going to do this. So we're going to simplify this first. Okay, we're going to simplify this. Because you notice the rules of algebra, we can square both of these things, and that becomes 4x squared. Okay, so that's the function we're going to look at. And now you notice that the first equation was written with a horizontal, technically a shrink, but in the simplified version, this is a vertical stretch, okay? Like I said, almost all horizontal stretches and shrinks can be written as vertical stretches and shrinks. So we're just going to work with vertical. So we're going to look at this new equation, okay? So first of all, you see the 4. That is a vertical stretch because it's greater than 1. By a factor of 4. And then we have plus 1 on the outside, so that is vertical translation of 1 unit up. Okay, so we expect these sides to be steeper and the whole graph to be moved up 1 unit. Okay, so let's look at this graph. So let's graph this. I'm just going to do my typical points. I'm going to square these. Negative 2 squared is 4. 4 times 4 is 16, plus 1 is 17. Really big, that's okay. Negative 1 squared is 1. 1 times 4 is 4. 4 plus 1 is 5. 0 squared is 0. Times 4 is 0. Plus 1 is 1. 1 squared is 1. Times 4 is 4. Plus 1 is 5. And guess what? 2 is also going to be 17. Okay? All right, so some of these points we can't graph. That happens sometimes. That's okay. So let's graph what we can. So negative 1, positive 5, 0, 1, 1, 5, and the other ones are off the graph. So you notice this is really steep, and it looks like that. And that is this g of x. And if you want to look at the parent function again, it's not a bad time to look at it, to compare. So you notice that the original one is a wider graph, so the new one is a more narrow graph. It is a vertical stretch, and you notice it is moved up 1 unit. That's as far as we're going to go with 2.1 in this lesson, and stay tuned for the next one. Bye.